Hello everyone. Let's wait till 6:10 and then we'll start. By that time, let's wait for others to join. By the way, we have another doubt session tomorrow. That doubt session we will revise whatever doubt, whatever things we have discussed till now, from start of this course till now. By the way, am I audible? Dhiren, am I audible? Okay. Let's wait for some more time. Generally, people join around 6:10, so then we will have a larger audience to discuss things. So things. Two more minutes and then we'll start. Okay, yeah, so 1, 2, 3, 4, 5. I'm sharing my screen and let's start. So, yeah, again, good evening to everyone. This is our technically, or I would say officially, last week-wise session. We have an extra session tomorrow, but this is week 12, last session. And I hope this whole course has been an entertaining ride for you. What do we call that? Uh, Fun ride, or what's the ups and downs we all have been through in this course. So I don't think like there have been a lot of downs, only ups here. Great learning curve and new things to learn. So uh, I mean, like you guys might have felt that. By the way, am I audible, Prabhu? Am I audible?
Ah, yes, sir. It is audible, sir. Good
Okay.
evening, sir.
Good evening. So I mean, all the courses which we study here, these all courses generally have one purpose. They tell the they are not these NPTEL courses are very short. In 12-week time, in this time of like this much small size, you cannot learn everything. So these courses just guide you towards something which you can decide later on. So this is a very basic course in machine learning. If you have taken advanced courses, then you will feel that those courses still are incomplete, and then you have to study a lot of things on your own. And that is the whole thing about learning curve of this whole life, not just online courses about technology. I mean, there are some lessons in life as well for which there are no courses available. So we learn on our own. So, anyways, a lot of philosophical stuff, and so let's start. Today we will discuss this year's week 11 and last year's week 12. Tomorrow we have an extra session, as I already told. Tomorrow it's session. We will discuss this year's week 12 and revise all concepts from surface level. Somebody has shared their screen or joined. No subtitles. Do you need subtitles or not? I mean, I don't feel the need. If you need subtitles, just let me know. Do you need subtitles? I'm closing them. I mean, they are distracting, at least to me. Um, okay. I'm trying to do something. It's not. Actually, I need to show my face all the time, so NPTEL policy. And PIP is not working. Anyways, let's start. So how many of you have submitted week 11? Successfully. Okay. Anyways, I'll go question by question. So okay. So what is a GAN? I've already discussed this whole thing in last class. So GAN network looks something like this. You have some real images. You sample some real images from that set. Then you ask generator to generate some sample images, given some random input. Then you want discriminator to basically create a discriminator loss and generator loss. So generator loss determines that these two images should be very close, while discriminator loss determines that these two images should be sufficiently apart. Okay, so there are two components, discriminator and generator. So this is the correct answer. I don't think so people will be having doubts in this. When a Gaussian prior is used in map estimation, what type of regularization does it correspond to? Let me ask ChatGPT. There is a doubt I have in this question. So let me ask ChatGPT. Is this visible? ChatGPT visible?
Yes, sir, it is visible.
Okay. So map estimation involves maximizing the posterior, which is this thing. Okay, so if we use Gaussian prior is this p theta. Okay, then p theta, log of p theta is proportional to this thing. So your map estimate becomes this thing, and this is equal to maximum likelihood estimation with L2 penalty. This is L2 penalty. Okay. So if you use Laplace prior, it is L1 regularization. If you use Gaussian prior, it is L2 regularization. Just remember this thing. It might be asked in exam. Why? Because like this question is clearly given to you, but in exam there might be some variance of this question. So this will be the correct answer. Okay. What is the input to generator network in GAN? I already showed this image here. It's a random input to generator. So random noise vector. Till now, any doubts? Okay, so what is the bottleneck layer in autoencoder? Do you know what bottleneck is? Is this visible?
Yes, sir, it is visible.
Where is the pencil? Let's see if I can start a whiteboard type of thing here. Okay, so see, I can draw. Yeah, nice thing. So this, assume this is your water bottle. Oh, I have a water bottle with me. I kept it for this purpose actually. I forgot. Oh, a lot of people have joined. Praveen, good evening. Amit, good evening, Amit. So attendance has went to 10. Okay, this is bottle. From your perspective, this is bottle and this is neck. The problem with neck, you can say, is it's thin. So if I have, assume I put this bottle contains, how much does it contain? How much does it contain? It's 500 ml. So if it contains 500 ml of liquid, and if this bottle had it been a shape of glass, and if I would have flipped it like this, whole 500 ml would have just gone like this outside the bottle, because the displacement volume at all cross sections is same. Okay, but in this case it will be a turbulent motion the first, because this liquid tries to push out, this liquid pushes the liquid downstairs, downwards, but this liquid here, it has lesser volume to escape, so it is a turbulent motion and it's not clear, so for water to escape, clear path. So bottleneck is the problem, which is not, which is bottleneck sort of, which is a limitation. The limitation is this bottleneck. Okay, so what is autoencoder? Let me show you autoencoder and then we'll discuss. This is not bottle, this is something else. Okay, so your autoencoder is something like this. Suppose you have some data here. Suppose you have some image here. This image, this image is of a cat. Looks a lot like mouse, but anyways. Okay. And now this image, you pass it to some encoder here. We use autoencoders to basically map these features to some other dimension. Okay, and then you put a decoder here. Okay, and you ask this decoder to generate a Ghibli image of cat. Now you might have known what Ghibli is. You might be knowing this thing. Okay, if you guys use Instagram, I don't know. Do you know what Ghibli image is?
Yes, sir.
Or shall I show you generating something? Okay, so I'll show you anyways. So the problem with this architecture is this looks like this, but in real it's like this. This is encoder. This is decoder. You take some data. Its data is 4096 cross 4096. Okay, and this thing gives the output as, assume 768. Now this 768 goes here, and you want the image of size 4096 cross 4096. So this is bottleneck. This dimensionality reduction is bottleneck, because you start losing a lot of information here. Okay, so like you have to encode this many to this much size. It's in the power of 10 raised to the power 1 2 3 4 5 6 7 8, and this is just 10 raised to the power 2 or 3 100, I would say, but 2 or 3, 7.68 into 10 to power 3, 10 to power 2, whatever it is. Okay, and then you have to basically reconstruct it. So this cost of reconstruction, or the loss during reconstruction, is high due to this dimensionality reduction. Okay, so the layer where dimensionality reduction occurs is the bottleneck layer in autoencoder. Okay, any doubts? Any doubts till now?
No, sir.
Okay. Which which is the key advantage of using variational autoencoder over traditional autoencoder? Let me show you the diagram of variational autoencoder. There should be some description here. Yeah. So as I showed you, you have encoder. It gives you some latent vector here. Okay, that latent vector is 768 dimensional, and you have to construct the image or data back. So you have some loss here. So loss is initial image minus final image. Final image is this thing. You pass z to this thing, which is you pass e theta over x. So this is your loss. Okay. Why use autoencoder for compression? We already know we need to reduce the size of data. Variational autoencoder addresses the issue of non-regularized latent space into autoencoder and provides generative capability. Okay. So here, if you see, it creates a Gaussian distribution over the data. Okay, you have given x, it finds the mean of x, sigma of x, and it creates a z sample here. Okay, it creates some sample z from this data, and it creates this vector from that z sample only. Okay, so if you see, d is mu x plus sigma x times something epsilon, and this is your reconstruction loss, and e theta of x, whatever you pass through encoder, you get these two values from there, and then you use this distribution to compute KR divergence over a normal distribution, over an identity distribution. Okay, so in this way, this latent space is distributed or normalized. So due to this normalization, this autoencoder basically saves space. I would say creates a uniform distribution, more structured and meaningful latent representation. Why? Because the real world, all real embeddings in the world, or if you follow deep learning, all of the embeddings are initialized using normal distribution only. It's mostly the variant of normal distribution. So it creates more meaningful representation if you create distribution something sort of that. Okay, so that will be the correct answer. Any doubts till now?
No, sir.
See, this is a simple question of bagging. So if you have multiple classifiers over a single classifier, what do they prevent? They prevent overfitting by splitting data into multiple features and rows, and it basically reduces the variance to some subset of models instead of all models. So they capture different aspects of data and reduce variance. This will be the answer. Any doubts here? Next question. Why might okay? Why might pre-processing to extract the region of interest be beneficial in MRI compared to using full image? So first of all, it reduces noise and it helps CNN to focus on the relevant structure you already know. Okay, so what happens is, let's zoom here. Assume this is my MRI scan, this is my brain. It has some deformity here, not my brain exactly. Some deformity is here. So what happens is, this whole brain is made of fat tissues and water. Is brain really a muscle? Is brain a muscle? Brain is not muscle. Brain is made of muscle cells. What is brain made of? Brain itself is not a muscle. See, brain is 40% water, protein, carbs, salts, 60% brain is fat. Okay, so I'm telling something very much biologically relevant because it's necessary for you to understand. So assume this is your fat cell. Okay, you pass four rays of uh, four rays of magnetism here, and it reflects three rays. One ray goes away. Okay, so what is the density of this? What is the, I would say it's 0.5, 0.75. What is the reflection power of this muscle, this tissue? 0.75. Okay, so generally when someone has some cancer or something, so in case of cancer, the brain is not brain exactly. Some cancer cells start accumulating, and those tissues are not fat. They are not made of fat. They are made of some different types of cells. Okay, which are darker in color, which might be okay. So when you pass four beams of light, one might go through, two might get absorbed here, and it will reflect only one. So it's 0.25% reflective power. This means this will be darker and this will be lighter. But we know that, now we have seen it, so we know that. So what we can do is we can create region of interest. So hello, hello, am I audible?
Yes, sir. Audible.
Internet
Yes, sir.
issues keep on happening. Okay, so I will go a little bit back. So assume you have this tissue. This is made of some cells which are not fat cells exactly. Its reflective power is 0.625, and it's darker. But this is lighter. Okay, 0.751. So what you can do is you can use some algorithm to extract intensity of image and create something like that. Okay, so create something. So if intensity is less than 0.50, less than sorry, if intensity is less than 0.50, you mark that pixel as 1. Okay, otherwise you mark that pixel as 0. So now you will have this thing, this whole image as 0 and 1. 0 0 0 0 0 0 1 1 1 0 0 0 1 1 1 0 0 0. Okay, now you have basically removed the noise. Okay, so what you do is you pass this image and you pass region of interest as well. Region of interest as well as this thing here. Both things go to a model, and now model learns using both these things, the image and this region of interest, and then it predicts whether the image has the cancer cell or not, because you will have some label data as well. It's raining here. Okay, so that is why this labeling is necessary. It reduces noise and helps CNN focus on relevant features. This is also the same case with cardiac muscles as well. Cardiac muscles are built using cardiac tissues, which are different from the other muscles. So if someone has cancer, that the presentation of cancer will be different. Representation will be different compared to normal cells. Easy question. Joint probability. It's learned by generator, but not discriminator. Discriminator learns this probability, posterior probability. Okay. Bayesian regression and map estimation. So map basically provides a point estimate, while Bayesian provides a distribution type of thing. Okay. Dice measures, this dice coefficient measures the overlap of segmentation. So what is dice basically? Let me tell you. Assume this is my image, this is ground truth, this is segmentation, this is prediction, this is the segmentation here. If I overlap them, this is ground truth, this is prediction. So you basically take intersection, how much is intersecting here, how much region, how much percentage of region is intersecting here. So assume say 0 point let's assume these are the number of pixels. Okay, so assume this region is this is 200 pixels are intersection, and total number of pixels here and here are 4000 plus 3000. So this will be the die score here. Okay, something like that. It is computed in this manner. Okay, so yeah, week 11 this week is done. Shall we start week 12 or any doubts you want to discuss here?
Sir, can you provide some guidance regarding the end semester exam? Like what kind of questions we can expect, how to prepare?
Tomorrow. That session is tomorrow.
Okay. Tomorrow session we will discuss, sir.
Yeah, tomorrow session we will wind up. That will be our last session, session number 13. And then we will see all the questions in that session. Possible questions. I will go through all the assignments and tell you what possible questions can you expect from these types of questions. Okay, and I've also given you the last year's assignments and solutions as well, so you can prepare through those questions as well. Okay.
Sir, last assignments where have you uploaded, sir?
If you open this sheet, if you open this directory here, you will find it. These are the assignments. Week 1 to week 11 I've already uploaded. Week 12 I will upload today. These are last year's assignment. 2024.
Okay.
Okay. Just a second. Let me check what's happening outside. It's either storm or it's raining. I don't know. Something is happening. Okay. Shall we go to week 12?
Sir, you are right now in Delhi, yeah?
Yes.
Okay. Which part of Delhi?
I am near Horse Khas.
Pardon me, sir?
Sorry?
Which part of Delhi?
Horse Khas. I'm in IT.
Achha.
Okay, so this was week 11 this year. Let's go to week 12 last year. Let me open the solution as well. Makes my job easier. Okay. Praveen, do you speak Hindi?
A little bit, sir. Not fluently, but I can understand a little bit.
Okay. Anything else you want to discuss? Because if I'll start this. If you want to discuss anything else, and then I can start this thing. Okay. Just a second. Hold on a second. I'm getting a call. Hello. You're leaving. अच्छा तो अभी you can lock it and keep the keys with you. अभी मैं GS रहा हूँ आपसे ले लूँगा आके ठीक है. ठीक है. Okay. Yeah. Okay. Hello. Shall I start?
Yes, sir.
Okay. I personally love this topic. Beautiful topic. So, if you guys want, I can take some sort of session on this topic. But anyways, we don't have sufficient time to study this thing. So yeah, let me open this sheet. It will be easier here. So surrogate models are what? What are surrogate models? These deep learning models are very basic. They can handle only some types of things. by learning so many complications in hyperparameters, okay? But there might be some things which are not very linearly or non-linearly, simply non-linearly related, okay? In that case, your systems is very I would say non-linear, and then use surrogate models. In that case, if you see, when system is complex, non-linear, potentially expensive, then they provide an alternative, okay, for faster optimization, etc., etc. Physics informed neural networks, apart from normal data, they also use additional physics equations as training data during learning. Training neural networks learn from physics. They basically enforce constraints alongside data. So the equations, the model adheres to the concepts of physics. Okay. To solve a one-dimensional steady diffusion equation, d square t by dx square equal to 0, where x belongs to 0 to 1, with boundary conditions t equal to 0, t equal to 1. Someone's mic. Computational domain into discrete points. In classical finite element, the solution of ordinary differential equation is approximated with linear combination of polynomial basis functions. In case of PINN, the solution is approximated with feed-forward network and deep neural network. Okay. So solution C. Underlying physics of problem, approximate solution by directly giving boundary conditions. Okay. In PINN paper, the gradients required are calculated using auto differentiation. So these are all the questions, like I cannot go through the concepts of them because the concepts are very high level. So if you go through these videos, okay, these videos, application 1, 2, 3, 4, you will be able to find some different viewpoint or perspective of these concepts. Okay. PINNs are mostly useful, suitable when we have say less amount of label data, along with some knowledge of physics in form of PDE or ODE. So generally ODEs and PDEs, it doesn't matter. Okay. So why do we need partial differential equation? Because we want to compute derivatives. We need the equation to be partially differentiable. Okay. Suppose we approximate the solution of 1D split diffusion through with a feed-forward network as shown in this figure below. With respect to neural network shown, the shapes would be, I don't know. This is a very complicated thing. I mean, this is the only part I generally don't study. I leave it to computer. So W3, this is W1. What are W1, W2, W3, W3? This is W1, W2, W3, W4. This is W1. This is W1, W1. W1 is applied to input layer. Okay, sorry. W1 is this thing here. So it should have input dimension to hidden units, so it should be 1 cross 2. W1 should be 1 cross 2. Who has messaged me? Just a second. Okay, so it will be 1 cross 2. Then we have 2 cross 2. And then we have 2 cross 1. So 1 cross 2, 2 cross 2, 2 cross 1. This should be the solution B. Okay, it's A. Input dimension. Input dimension is 2y. solution given here is wrong, because if this is 2 cross 1, then this should be 1 cross 2, but it should be B. Okay. If this is correct, then this is also correct, but the correct answer is this one. Anyways, MSE U is some initial boundary condition, initial data plus some boundary condition, that U is initial data, and MSE is your mean square error of the boundary. F is the mean square error of differential equation, so residual. So these all things are given in this paper. Okay, so if you open this paper here, these all things you will find here. Okay. We wish to solve Laplace equation using PMRF approach. The approximate network structure would be okay. 3 inputs representing special. And 1 output should be the solution. And as many hidden layers we want. So it should be 3 inputs should be for X, Y, and Z, and output should be U, and as many hidden layers as we can have in between. So it will be X, Y, Z, blah 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 blah, whatever in between, and then U. Okay. Which is true in case of PINN. So there are multiple true options here. Not exactly. Boundary conditions are satisfied only approximately. ODE is converted to optimization problem, already told you. You differentiate it and you find the local minima maxima. It uses automatic differentiation to compute derivatives. Yes, I've already told here. It uses auto differentiator. Where was that question? Auto differentiation. Okay. So yeah, this was week 12. This was the only week with something completely different from whatever you have studied till now. Like this involves some sort of real world information, real world physics to be solved using machine learning. Okay, so that would be all for this week as well. Any other doubts?
Actually, for that Laplace equation solving, why we are using ANN and not CNN? And question number 9.
If CNN is there, it should also have some 3 inputs. 3D, the problem with 3D is it has to, the 3 inputs interact with each other. The problem with 3D image or something like that. Okay. So one thing is CNN. This CNN would be an overkill. Okay, and another thing is this is not the correct option. The output of CNN is not given. We can use CNN as well. Wherever you are using ANN, you can use CNN. That's not like very hard and fast rule. CNN, wherever you use CNN, and in that place you might not be able to use ANN, but wherever you use ANN, you can use CNN. Okay, the option was incomplete. Otherwise, it would have been correct. Okay.
Oh, okay, sir.
Any other question?
Hello, sir, can you hear me?
Yes.
Yes, actually, the test will be like a open book test, or it's
not open book.
kind of, it will be open book, right?
Yeah, it's closed book. You cannot bring any piece of paper there. You have to remember everything in your brain and you have to write it, or you have to tick it. It's basically multiple select, like the assignments, the kind of assignments which you had. The final exam will be in that format only.
Okay. It's like the computer will be with the internet, right? Are we free to browse?
Yes. No, you won't be able.
Okay.
No, you won't be able to browse anything. If you switch the panel from test, your test will be ended. You cannot browse anything. You can just use calculator.
Oh, you can't browse it. Okay.
You can just use on-screen calculator, nothing else.
Oh, okay. So cell phones are allowed, sir?
No, nothing is allowed.
No cell phone is allowed.
It's like an exam which you give in your university, just computer-based exam and MCQ-based exam. Nothing else.
Oh, okay.
Sir, closed book, na sir?
Yes, closed book.
Okay, formula sheet, nothing is allowed.
Nothing is allowed.
Okay.
Like, it's a normal exam which you have. Like, I don't know, are there exams which allow mobile phones or not? I don't think so. So I think that it's like that only. Any other question, Prabhu?
Actually, so how to prepare for the exam? Like when we are watching videos, like what are the things we should focus?
Focus on topics. Okay, right? Take a paper. Write what topics you have been taught. Okay, and have you prepared that topic well? So if you have been taught CNN, okay, so what are four things in CNN? So do you know those three, four things clearly? Do you know what is file? What do you know what is padding? Do you know what is this? So if you have been taught, say, RNN, so what are three things in RNN? If you have been taught, say, assume this thing, what do you call that? Bayesian, Bayesian inferencing or something like that we have been taught. Probability. So what are three, four topics you have been taught? So you have to prepare topic wise if you want to pass exams. For learning, you can watch videos again. Just for exam sake, you have to revise all the assignments again. All the assignments, I mean, this year's as well as previous years. So let me upload the solution here. Let me upload this solution. Okay, so week 12 is uploaded. So you can find it here. Okay. So revise all the assignments. That is the best approach to NPTEL exam. If you do not revise assignments, you will suffer because 50% questions are generally from assignments as it is. Like a few changes here and there, but 50% of the paper is from assignments only. The other 50% will be somewhat from assignment, but it will be a bit difficult. So I assume like you are solving this thing here. So it will ask what is MSEF, what is this thing, what is that, what is blah. It will not ask this thing directly. The question might change a bit that way. Okay. So 75% of this paper will be from assignments as it is, and the remaining 25% will be from videos only. The things which might not have been given to you in assignment, but from videos only. Okay.
Okay, sir. Okay, sir. So basically, sir, another doubt, like it will be theory type or problem type or.
The assignments are like a combination of all the things. There's
Okay.
theory, there's question answers, there's like numericals, there are multiple select questions. Okay, there are reasoning based questions, so it's like that only.
Okay.
Exam won't be something very much different from assignments only. The format in which you have given assignments, like prepare in that way only. That is sufficient.
Okay, sir.
Okay.
Okay. Like coding and all will not be required because access will not be.
No, coding won't be required.
Okay. Okay.
If you are asked to derive, if you are asked to find the parameters or weight, something like that, okay, then you have to solve the equations. There are
Manually.
yeah, compute derivatives, solve them.
Okay.
Okay.
But it will be long, or it will be easy, like one iteration, two iteration, like that. It will be told. Right?
Yeah, I mean it is difficult to compute on the go. I mean there are some problems of computing, remembering if you're like backtracking all the errors. It is difficult, but ultimately solving it by hand is the only solution. Otherwise, if it's that difficult that only computer can solve it, that question will not be given to you.
Okay, sir. Okay.
Okay. Another question?
Well, actually, some portions are very difficult to understand, sir, from the lecture. And it's very mathematical. So what to do in those cases?
Google search.
Okay.
Okay, so if you find some question difficult, it's the problem might be you do not know the concept well. Okay, so in that case, just search the question first, see the solution which is given by Google, go through that solution, and then study that concept well from that solution, and try to backtrack it. Try to backtrack and go to see other solutions or other topics or other web pages where that concept is told you. So in that way, you can solve it.
Okay.
Yes, sir. How long the videos will be there, sir? Like, will it be blocked after 27th of April, or it's like?
Sorry?
I just want to get it downloaded. So, how long the video will be there? Like the lecture videos?
Lecture videos are forever.
It will be there forever, is it?
Yeah. You don't need to download it. By the way, these videos are already on YouTube. Okay, so they have been given to you here just for that sake. But they are, if you open them, the link already points to YouTube. See, so they are not deleted. They are not deleted anyhow. If I open this video, see.
Okay.
Sorry, this is not a video. These are YouTube videos only. If I go to here,
Okay.
I will be going to YouTube channel. Okay. And so this is IIT Madras' YouTube channel here. And if you go to playlists, you will find all the courses here.
Okay.
So these videos are mapped from here only. They are not edited, they are just remapped again and with new assignments. So videos are old, the assignments are new. Okay. So if you go here, and so you can also find a playlist. Which playlist does it belong to? So see, this is course, it's given like this. Okay, so this is NPTEL. This is NPTEL thing.
Am I audible?
Sorry?
Can you hear me, sir?
Yes, yes.
Sir, I have a question regarding the final examination. In the pattern of the examination, that is, will there be any other exam, online exam before the final examination, sir? Like say, for example, if the total distribution of marks is like 25%, 50%, or 25% for the assignments, or 75% marks for the final
There will be
examination.
just
Like that,
one final exam. Just one final exam. Okay, there will not be any exam apart from that final exam, which is on 27th April, or I don't know what date it is on. There will be just this week's assignment, week 12 assignment will be there. After that, you will just go to the center and give exam. Nothing else in between.
So after the 12th week assignment, there will be only final examination.
Yes, no assignments, no exams, nothing online. The only week session will just weekly doubt session will be there tomorrow. Apart from that, nothing will be there.
Okay, thank you.
Okay.
Yes, sir. Thank you.
Okay. Any other doubts? No mock tests. It's already told, I think, that previous year's questions will not be available, and these mock tests will not be available. If you want, you can just see this NPTEL mock test. Okay. So I don't know what is that. I think this is gate or something. Mock tests basically tell you like what kinds of questions will come, but ultimately your assignments are mock test only. The assignments tell you what kind of questions will be coming in your exam. Okay.
Yes, sir.
So yeah, I mean, don't don't get confused. It will not be a difficult exam, but it will be a comprehensive, thorough exam. You have to study everything from start to end. It becomes difficult, I know, to study all these things, but there is no other way. I mean, so yeah, anything else? Any other doubts about exam or anything?
So, can you tell the how many number of questions and how
Generally,
much
there
time?
are generally
3
there are
hours
40
and
to 50 questions.
50 questions, 3 hours.
Yeah, something like that. Okay. So
Okay.
there might be 60 questions as well. If there are 60 questions, then the questions will be easy. Okay.
Oh,
If there are 40 to 50 questions, then
this is
say assume there are 50,
moderately difficult.
yeah,
Moderately
no, no, no,
difficult.
no. If there are 50 questions, then assume 40 will be easy and 10 will be moderate. Okay. If there are 60 questions or 70 questions, 60 or 70, then the questions will be easy. Okay, it's something like that. This is just a hard and fast rule to keep you engaged for at least 1.5 hours.
Okay.
So it's not, if I give you 20 questions, you can just solve them and go away in like 30 minutes. So we have to keep that thing in mind as well.
Yes, please.
Okay, any other doubts? I told earlier as well, I'm telling again, if you want to study anything about machine learning, this book is Bible. This book is the Bible of machine learning. You can just download it here itself. You might need it when you start studying about neural networks, backpropagation, etc. This is VAE, etc. Everything PCA, VAE. Okay. This book will solve all your doubts. If you are studying it, like if you have time to study, like if you have some doubt in some topic, you can go through that topic in this book and you will find a nicely written explanation. Okay, any other doubts?
Sir, can you also give some list of topics, sir? Actually, it will be easy for us to cover.
Well, how should I say? Like, I don't know. I don't make the paper, so what topics can be important? This is very important. Okay, this week is very important. I mean, you can skip this one. This is easy. This is important. CNN is easy. Okay, this week is important. Obviously, probability and linear algebra are important. Week 1, week 2 important. You can skip. If you don't like easy, this is easy. I'm not saying to skip it, but you should focus on week 1, week 2 a lot. Week 4, this you can skip a bit. I mean, do not need to focus a lot. This you need to study clearly. This one, and this one. You can skip 2-3 weeks, but I would suggest study everything.
Almost you covered, sir.
Yeah, I mean, if something is important, that's why it's taught.
So is there any specific reference or book for a mechanical application with the machine learning, sir?
No idea. I'm not from mechanical, so I don't have any idea. You can search Google. If you find something, just let me know. I might go
Okay.
through it and see if the book is useful. Otherwise, if you ask me personally, I don't know.
Okay.
Okay. Any other doubts? Anything else you want to ask, or then we can end the session and let's meet tomorrow. If you want to ask anything, just go shoot.
Sir, tomorrow, sir, you can just give a recap, sir, of the.
Yes, that is what I will give. Tomorrow I will go to week 1 and tell you what topics are there in week 1, then week 2, then week 3, what topics are important there, everything. Okay?
Okay, sir.
So don't worry about it. Tomorrow will be revision sort of stuff.
Okay, sir.
Okay. Okay, so like if you have any other doubts, just shoot, otherwise we can end the session.
Okay, sir. Thank you, sir.
Prabhu is very.
Nobody asked
Okay,
a
sir,
question.
thank you, sir. Bye bye. See you tomorrow. Straightforward session ended. Chalo then, cool. Let's meet tomorrow, same time, 6 p.m. Okay. Then we will discuss everything, and I don't know, like. Uh, we will try to solve. We will try to just memorize some expressions, some derivatives, so that if that question comes, you don't have to derive everything. Okay. We will try to create some common expression for some linear regression derivative and logistic regression derivative, so that you don't have to derive there and solve it. Okay, so that will help you. If something like that comes up, derivative related, just find derivative after first iteration, second iteration. Those were one of the most difficult questions, I would say. Not difficult, lengthy or tedious questions. So we will try to come up with some short methods for that, and then let's see how things go.
Yes, sir. Saving time is important. That kind of question. Yes, sir.
Yeah. Okay then, chalo. Bye bye. Good night. Take care.
Thank you, sir. Thank you all.
Thank you, sir. Okay, sir.